In this session, we focus on the outcomes and results of co-creation. Previously, we have explained what co-creation is and why you should co-create in research and innovation. We have argued that it may be necessary to provide compelling examples of what can be achieved through co-creation and how it can be done in order for research and innovation actors to consider and adopt co-creation approaches. We will now seek to do that by showcasing the findings from the various events in the co-creation process in the GoNano-project. Lastly, we will also discuss the elements for building a business case for the co-creative approach. We have presented the methodology of the GoNano co-creation process in previous sessions, but before we cover the various outcomes and results from the co-creation pilots in the GoNano project, we will just briefly recap the design of the co-creation process to ensure that everyone watching this is on the same page. GoNano established an iterative four-step co-creation process to integrate societal considerations in nanotechnologies, which we tested through pilot studies in the Netherlands, the Czech Republic, and Spain. The first step consisted of a series of citizen workshops, where citizens expressed their wishes and concerns with respect to each of the application areas, health, food, and energy, respectively. In the second step, the pilot partners organized co-creation workshops with stakeholders to explore ways to take the wishes and concerns of the citizens into account in nanotechnology research and innovation. The result from the first stakeholder workshops were subsequently discussed in the third step of the co-creation process, an online citizen consultation to get responses from citizens from various European countries to the product suggestions of the first round of stakeholder workshops. The fourth and final step of the co-creation process consisted of a second round of stakeholder workshops in each of the pilot countries. These workshops explored how the product suggestions derived from the first stakeholder workshops and the subsequent input from the online consultation could be integrated in concrete research and innovation decisions. The table here gives an overview of the type of input, outcomes, and data gathered at each of the four steps in the co-creation process in GoNano. In the next part of this session, we will give an account of the outcomes and results from each step in the pilot studies. Participants in the 3 citizen workshops were active and motivated. They were able to discuss possible application areas of nanotechnologies, and they formulated a number of common wishes and messages. Their messages and wishes were very often illustrated and/or accompanied with a model of possible nanotechnology application. The social needs and values that we see across all 3 nanotechnology application areas in food, energy, and health are summarized in the table in front of you. In general, the discourse from the citizen workshops reproduced well-known repertoires of optimism and concern. Public perception studies consistently show that European citizens are cautiously optimistic about nanotechnologies. They have positive expectations. However, they also have concerns about the risks to human and environmental health and to societal well-being in general. The results from the citizen workshop suggest that citizens recognize and appreciate the promise of nanotechnologies, but they also realize that benefits might not follow automatically from scientific progress. In terms of benefits, citizens pointed to a number of desirable applications that would reduce the use of food and energy, increase health and well-being, or make water more available to more people, especially in the third world. Their recognition that benefits might not follow automatically from technology development is seen in them asking the relevant stakeholders to make sure that nanotechnologies do not harm our natural environment or the human body. A number of values and needs cut across all the citizen workshops. They include sustainable development and consumption, human health, environmental protection, safety aspects, affordability, and accessibility. Citizens expressed various values and needs when it comes to nanotechnologies in food, energy, and health. The wideness of these values and needs can be explained by their origins in both fears and a general understanding of the great potential that nanotechnologies have. The more specific requirements are mostly connected to safety, the environment, human health and well-being, affordability, and accessibility of future technologies. Collectively, the first round of stakeholder workshops in the 3 pilot countries mobilized almost 100 stakeholders around co-creation and nanotechnologies. The events provided productive spaces for engagement and mutual learning between a wide range of stakeholders, including researchers, producers, policymakers, civil society organizations, and citizens. The workshop discussions gave rise to interesting suggestions. In the diabetes workshop at University of Twente in the Netherlands, Citizens' concerns about the ownership of medical data sparked a discussion about data management in the case of the artificial pancreas, highlighting considerations that might be of use to the product developer in further developing a data management plan. In the sensor workshop, interactions with envisaged future users of a biomedical sensor raised the researchers' awareness of the performance criteria that will determine adoption of the sensor. These examples suggest that exposure to use considerations further down the line can attune research design to future use contexts. The overall workshop approach of enabling carefully moderated, highly focused, interest-driven discussions in a four-step process of exploration, ideation, prototyping, and reflection seems to have worked well in these cases. Looking at the learning objectives for the stakeholder workshops, the results suggest that, at least in some cases, the workshop succeeded in raising awareness with stakeholders that the early consideration of the needs and values of citizen and societal stakeholders can add value to innovation in nanotechnologies. However, it seems that participants valued the workshops not just because of a direct self-interest, but also because they provided general opportunities for mutual learning and networking opportunities. Exposure to different perspectives was considered an enriching experience in itself. The workshops raised a general awareness with stakeholders of the need to incorporate social needs and values in the development of nanotechnologies. The online consultation served to broadly evaluate the outcomes of the first two steps in the co-creation process. Respondents in the Czech Republic, Denmark, Ireland, the Netherlands, and Spain connect nanotechnology in general mostly to its specific characteristics, especially its advanced size, and to non-specific ideas connected with advanced technology or the future. What can be considered rather successful seems to be the incorporation of as many views as possible, including people from various socioeconomic backgrounds, city size, but also lower educated participants, as the overall percentage of respondents with primary and secondary education accounts for 54% of the answers of all the respondents. The overall current sentiment towards nanotechnology seems rather positive, with 55% of the respondents stating mostly positive or positive attitudes. Moreover, this seems to be somehow connected to respondents' perception of themselves being well informed about nanotechnology. When free to choose, respondents often wish to discuss health applications. Specific product suggestions in health are on average also the most popular ones, with improvement of diagnosis of cancer through monitoring proteins and early diagnostic devices being the most desired product suggestions of all the application areas. Health and food application areas are somehow more associated with safety concerns than the implication area of energy. Subjectively perceived, unsafety of a product suggestion and the desirability for the same product suggestion correlate only weakly when compared to moderate correlations in health and food product suggestions. The least safe perceived product suggestions are connected with food with a balanced mix of nutrients and, surprisingly, analytical methods for the detection of nanoparticles. Needs and values connected to safety are at the same time the most prioritized one by respondents in both the food and health application areas. Concerning stakeholders and their responsibility for the safe development of nanotechnology, respondents stressed the key role of researchers in the process, followed by stakeholders from business and policymakers. The second round of stakeholder workshops explored how input from citizens can be productively engaged in concrete research and innovation decisions, taking the product suggestions derived from the first stakeholder workshops and subsequent input from the online consultation as a starting point. These workshops explored how the main actors identified in these product suggestions, the so-called problem owners, could mobilize the considerations of citizens and other stakeholders to co-create more socially robust research and/or product suggestions. The results from the evaluation indicate that participants highly appreciated the events in all three pilot countries. Participants were positive about acquiring new information, fresh ideas, and new perspective on research and innovation. Many agreed that the early consideration of societal needs and values can add value to innovation in nanotechnologies. The stakeholder workshops show how bringing stakeholders with different backgrounds together leads to relevant discussions and insights for product development and research projects. The relevance of this finding should not be underestimated. The productive integration of societal considerations in research and innovation will depend on mutual learning between stakeholders, on the shared realization that broader societal perspectives matter. The overall GoNano experience has elucidated opportunities and challenges of co-creation as a tool to enhance the responsiveness of research and innovation. The findings of the GoNano co-creation process confirm that with some effort and careful preparation, it is possible to demonstrate to stakeholders that it does make sense to look at the broader dimensions of research. Participants valued the general opportunities for mutual learning and networking. However, getting from constructive dialogue to practical action remains a significant bottleneck. There is a gap between the appreciation of broader issues around research and innovation and the actual integration of those issues in daily research practices. The GoNano experience suggests that co-creation processes need to identify the concrete interest and address the motivations of all participants, maintain continuity of thought, translate needs and concerns from the social realm to practical options in the technological realm, and drill down to the level where the discussion topics and identified courses of action are specific enough to affect the decisions of the actors involved. How does business and co-creation match? There is indication that co-creation could enhance the reputation of businesses, cut costs, stimulate innovation, as well as provide opportunities to shape regulation. For example, the Prisma project recently identified several cases where the application of responsible research and innovation potentially add value in a commercial context. The BASF Creator Space has also produced several examples of where co-creation made business sense. These projects include a business model for greenhouses and urban environments using multiple BASF technologies, a bio-based recyclable monomer, and the novel use of materials to create minimally invasive underground water storage capacities. The co-creation process within the GoNano pilot studies did in some cases suggest how the process could make business sense. User-producer interactions on the artificial pancreas suggested data management and visualization considerations that might be relevant for the future design of the device. The co-creation sessions on the biosensor for cancer diagnostics help shape future research directions for the postdoc. And the discussions on energy storage and capture suggested how societal consideration can help envision new applications for wireless sensor nodes. In order for co-creation and research and innovation on nanotechnologies to make business sense, it needs to be clearly demonstrated how the integration of societal considerations leads to new business opportunities. For instance, by stimulating innovation, enhancing the company's license to operate, increasing brand value and customer attraction, or by lowering the costs of control measures and regulatory approval procedures. To realize this potential, the GoNano co-creation methodology will need to be adapted to business contexts. The GoNano business case will provide a deeper analysis of the business case for co-creation in nanotechnologies when published later in 2020. In this session, we sought to provide compelling examples of co-creation and the added value from it by showcasing a variety of outcomes and results from the co-creation process in the GoNano project. In the next session, we will present our recommendations for policy to support responsible research and innovation practices.